So let's take a look at arc length of parametric equations. So parametric equations are designed to track moving objects. The arc length would be the length, how far that object has traveled. So it's a pretty good concept for parametric equations in particular. So I'd like to find the arc length of this parametric equation, and I'm going to start using a formula that you may have seen in a previous calculus course. Here's arc length. Let's suppose y is a function of x. And I'm going to say x is in between two other numbers, c and d maybe. The arc length is an integral. The integral from c to d of the square root of 1 plus the derivative dy dx squared. So I'd like to adapt this for a parametric equation. So here is arc length for the parametric equation. I'm going to take this and turn it into an integral with respect to t. So I'm going to do a substitution, like a u substitution, but I'm not going to use the letter u. I'm going to do a substitution. I'm going to say x is f of t. So that's my substitution. And when you do a substitution, turning one integral into the other, you have to change the dx into a dt. So I'm going to take the derivative, and I'm going to get dx dt is equal to f prime of t like this. So in other words, some people like to write this as dx is f prime of t dt. So I'm going to do this substitution and turn my integral into an integral with respect to t. So I get the integral. Now I'm changing from x to t. X goes from c to d, but t is going to go from a to b. So t goes from a to b. I'm going to rewrite this derivative dy dx in terms of a t. We know how to take derivatives of parametric equations. You do that by taking dy dt and dividing by dx dt. Then I'm going to change the dx into f prime of t dt. I'll simplify this a little bit. So this is really equal to the integral from a to b. And then I'm going to factor out a dx dt from the square root. So I get dx dt squared plus dy dt squared. And then I'm factoring out a 1 over dx dt. So I should write 1 over dx dt. And I still have this f prime. F prime, that's the derivative of x with respect to t. So I'm going to write that as dx dt, and then I have this dt. So what did I just do? This term here, I factored out of the square root. You could see that if you put this back into the square root, you'd have to square it, of course. These first terms would cancel and give you 1, and then the second terms would combine and give you this. So I haven't really changed anything. I just rewrote the problem. And then maybe now you can notice that these terms cancel. And I'm left with the arc length formula for a parametric equation. Let me write it down for posterity. It's the integral from a to b of the square root of dx dt squared plus dy dt squared. dt. So let's write down arc length is equal to this. Let's do an example or two. So here's a nice simple example. The arc length of the parametric equation x is cosine t, y is sine t, and t goes from 0 to 2 pi. That parametric equation we've seen a couple times before. It's a particle moving around a circle in the counterclockwise direction exactly once at constant speed. So the arc length of this parametric equation we can find just by doing an integral is the integral from 0 to 2 pi, the square root, the derivative of x squared, so negative sine x, sine t squared, plus the derivative of y squared, so plus cosine squared t. Now we all know the identity sine squared plus cosine squared is equal to 1. So this is just the integral from 0 to 2 pi of 1 dt, which, if you evaluate, gives you 2 pi. That's what I would expect. That gives me the circumference of a circle of radius 1 is 2 pi. Let's do one final example. How about the arc length of, let's do the parametric equation, x is 1 plus e to the negative t, and y is equal to 2e to the negative t. And let's say t is in between 0 and 1. Okay, well this is simply the integral from 0 to 1 of the square root of the derivative of x squared. So the derivative of x is negative e to the negative t, so that's squared, plus the derivative of y squared, so that would be negative 2e to the negative t, and I integrate this. Well, just simplifying a little bit, you turned out to be a pretty routine problem. So this would be e to the negative 2t, and this would turn out to be plus 4 e to the negative 2t. That's the integral from 0 to 1, the square root of 5 times e to the negative t dt. And finishing up the problem, integrating, I get negative square root of 5 e to the negative t evaluated at 1 and 0. So the final answer, plugging in 1, gives me negative the square root of 5 e to the negative 1, and then subtracting and plugging in 0 gives me plus root 5. Remember, e to the 0 is equal to 1. So there's the arc length of this parametric equation. Okay, fantastic.